Okay, now we were here. This angle is angle subtended by A to B2, that is the final image at the eye is beta, and at the same place, means at the least distance of clear vision only, we have brought the object also, and it is subtending an angle alpha. Fine, it's there. Then according to the definition which we have already mentioned, m should be equal to beta by alpha, should be again tan beta by tan alpha, due to the same reason, again for small angles. I can write. Then it should be, what is tan beta? Look, A to B2 by B2E. A to B2 by B2E divided by PB2 by B2E. I hope you understand. Tan beta and tan alpha we have already here mentioned. This is, then B2E cancels. We are getting A to B2 divided by PB2, and PB2 we have already cut an intercept. M is equal to A to, I write here A to B2, okay, divided by AB first. I write here. No problem. PB2 is equal to AB. It has been written like this. Now I write A to B2 divided by A1 B1 into A1 B1 divided by AB. Look, simple mathematics. What I have done mathematically, A to B2 by A1 B1, I have divided it by A1 B1. A1 B1 is the size of this image, first image. So I have divided it by A1 B1. I have multiplied it by A1 B1, also the same, this factor. Then it is cancelled. So ultimately what I am getting, what is this? It is the size of the image by size of the object for eyepiece. That's why can it be written as ME into MO. Look, these are the linear magnifications. Understand? For objective, AB is the image, A1 B1 is the object. Size of the image, size of the object. Here size of the image, size of the object. You can very easily understand here that why magnifying power has been increased by such a large value, because it has been multiplied. Magnifications are multiplied. That's why it's happening. So this is there. Now what I write? Now for lens E, I write. For the lens E, let us see. Here, I have already told you this distance is UO. Okay, this distance is VO. Okay, that means UO and VO are the image distance, object distance and image distance for the objective. This is UE, object distance for the eyepiece, image distance for the eyepiece. For the lens E, first I find 1 by VE minus 1 by UE is equal to 1 by FE. Alright, this is the lens formula, but with sign. Look, VE is negative because incident rays towards right, opposite direction. VE is negative, UE is also negative, but FE is always positive. So it is negative and it is negative. I write here with sign. Okay, that means minus 1 by V plus 1 by UE is equal to 1 by FE. Or we can write multiplying both sides by V. You can write multiplying both sides by V. Can I write 1 plus minus 1 plus V by UE is equal to V by FE. Or we can say V by UE is equal to 1 plus V by FE, which implies ME is equal to 1 plus D by FE. It is very much identical with the clear vision for simple microscope. ME, value of ME we got. Now for the lens O. Let us now discuss it for the lens O. Alright, for the lens O, let us see what happens for the lens O. It will be 1 by VO minus 1 by UO is equal to 1 by F1. Obviously, for the lens O, it will be like this. Let us apply sign. Sign UO is negative, VO is positive. So I can write here minus. Here again I write with sign. So we can write 1 by VO plus 1 by UO is equal to 1 by FO. Alright. Multiply both sides by VO. Multiplying both sides by VO, how much we shall get? 1 plus VO by UO is equal to VO by FO. It means what we get? VO by UO is equal to VO by FO minus 1. Look, this we are getting. Then what is our final expression? How can we write our final expression? So final expression here, I am again going back to this. Then we can write M should be equal to, I can write here VO by FO minus 1 for MO and 1 plus D by FE. Okay. 1 plus D by FE. VO by FO minus 1 into 1 plus D by FE. Very clear. When the final image is formed at least distance of clear vision, when the final image is formed at the least distance of clear vision, we can get this result. Look at this. Here we are getting this result, and now see this result we have got. If you are asked to determine the distance between both the lenses, suppose you are asked to determine the distance between both the lenses. Distance between lenses, that is L, must be equal to how much? OE. OE is the distance between the two lenses. I write VO plus UE. But mind this, one thing should be very clear. When you are writing VO plus UE, it means this UE should be always written positive because it is the magnitude. That's why what I do when I teach normally, I put it like this within bars, because what happens sometimes student may put here the sign convention by mistake. They put sign convention. If you put the sign convention, VO will be positive but UE will be negative. Then you cannot get the distance, it will be decreased, it will be subtracted. You understand what I am saying? So you have to be very careful when you are doing this, you have to put it in this way. It's alright. I hope, dear students, you have understood it. This is the whole thing about the magnifying power, and this is the whole thing regarding the distance between the two lenses. Alright, so this thing we are getting for the clear vision. Okay, in this you can say in our NCRT question number, NCRT, I write here NCRT question number 9.11, if you try, question number 9.11. If you try, that is the question of the compound microscope, and the question is for both the settings, for the least distance of clear vision as well as for the normal adjustment. And I hope the formula which I have shown here, if you use this formula, you can solve that question. Okay, right? So this is the whole thing I am getting in case of the compound microscope. Alright, in case of the compound microscope, here this is the whole thing I am getting. You can see in this question number 9.11, in that FO is given, objective has the focal length, FO is given to be equal to, okay, 2 centimeter. FE is given to be equal to 6.25 centimeter, fine, 25 centimeter, and they are separated by a distance L. It is given to be 15 centimeter. Okay, these things are given. Correct. How far from the objective the object should be placed? Okay, you have to determine the value of UO. Should be placed so that the first part is when the image is formed at 25 centimeter, this distance of clear vision, and second is for infinity, when it is at infinity. I hope only those formula which are here, with the help of these we can determine, and you have to find out the magnifying power of the microscope in each case. So microscope ka magnifying power you can do here. I think these data are given, only these 3 data are given, so you have to determine those things which have been asked. I hope you can try this part. Followed? I hope it is clear to all of you. This is regarding the clear vision. Alright.